the last thing in this section is solving using the quadratic formula or quadratic equation. So what we're going to be doing is we're going to be taking our quadratics, make sure they're always equal to 0. You always got to be equal to 0 first. We're going to take our quadratics and plug those into the quadratic formula. So let's first write out the quadratic formula. It's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, when you have a quadratic, the first thing is always your a, second is b, third is c. Now on 15 we have a unique situation. We have x squared and we have 25. We're missing the x that should be in the middle. If you look here on the 18, you'll see that there's an x in the middle. We have x squared, x, and then the number by itself. So there should be an x here in the middle. So that means that the x squared is your a, and the 25 is your c. There is no b. So when we plug in b for this one, it will just be 0. All right, so let's give the first one a try. So we have x squared plus 25. The x squared is your a, the 25 is your c. So let's plug it in. We don't have a b, so that would just be 0 plus or minus the square root of 0 squared minus 4 times 1 times 25. All right, and then on bottom would be 2 times a, which a is 1. All right, the first thing you always do is the discriminant. That's the part that's underneath the square root. So we're going to do the discriminant first, and this will determine or tell us what type of problem this will end up being. So let's do what's underneath here first. All right, so that would be 0 squared minus 4 times 1 times 2, which comes out to be negative 100. So our discriminant is negative 100. So this tells us two things. First, it's negative, so that means this is going to be a complex or imaginary quadratic. That means we're going to have an I whenever we finish it out. Now, also, it gives us 100, and we know 100 is a perfect square. So what that means is we do not have to break down the square root into perfect squares or just simplify it. We're just going to have to take the square root, so that'll make it easier. So let's look at what we have now. 0 plus or minus the square root of negative 100 all over 2. Now we can just get rid of this first 0. We don't need it anymore. So we're just going to have plus or minus the square root of a negative 100 over 2. So the first thing we have to deal with is this negative on the 100. So to take the negative off, all you do is put a I on the outside and drop the negative. So what that'll become is plus or minus I square root of 100 all over 2. All right, so now that we've got the negative off, we can take the square root of 100, which is 10. So that will be plus or minus 10i over 2. And then we simplify. So that's 10i over 2. So 10 divided by 2 would be 5. So our final answer would be plus or minus 5i. And that would be our final answer. So the answer would be a positive 5i and a negative 5i. So that is the solution for x squared plus 25 equals 0. All right, now for the second one, we have 2x squared plus 2x plus 3. So let's plug everything in and see what it looks like. So first, negative b, so negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 2, times c, which is 3, all over 2a, which is 2. All right, so again, we're going to do the discriminant first. We're going to do what's underneath the radical first. Remember, don't take the square root of it yet. Just do what's inside of it first. And when we do that, we get negative 20. So again, this tells us two things. First, it's a negative. So that means we're going to have an I in it because it's going to be imaginary or a complex number or complex quadratic. And then it has 20 on it. So 20 is not a perfect square. So what that means is we're going to have to simplify or break down 20 using perfect squares. So let's rewrite what we have so far. Negative 2 plus or minus the square root of negative 20 all over 4. So the first thing I'm going to do is I'm going to take that negative off and make it an I. So negative 2 plus or minus I square root of 20 all over 4. So what I need to do now is take this 20 right here, which is not a perfect square, and simplify or break it down using perfect squares. So the first one I can think of is 4. 4 is a perfect square, and it'll go into 20. So let's take a look at that. So when I divide 20 by 4, I get 5. So that and 5 is not a perfect square also, but it can't be simplified anymore. So I'm going to replace the 20 with square root of 4 times the square root of 5. So I have negative 2 plus or minus I square root of 4 times square root of 5 all over 4. So what I did was I took the 20 and I replaced it with 4 times 5. Square root of 4 times square root of 5. The reason for that is now I can take the square root of 4 and get negative 2 plus or minus 2I square root of 5 all over 4. So what I've done now is instead of leaving it as square root of 20, which is not a perfect square, I have simplified or broke it down using a perfect square, which was 4, and now I'm able to pull out a 2I from that square root. Now, we're almost done. The only thing we have to do now is simplify. So we have negative 2, a positive 2I, and 4. So it's negative 2, 2, and 4. So we can simplify this down by dividing all of those by 2. And our final answer would be negative 1 plus or minus I square root of 5 all over 2. Because we would divide each of these by 2. Negative 2 divided by 2 is negative 1. 2 divided by 2 is 1, or we can just write I, and then 4 divided by 2 is 2. So that is how you that's how you solve quadratics, by using the quadratic formula. So we had one that just came out to be a normal complex. We had one that came out to be a radical with a complex number. So those are two of the harder types. There are easier ones, but I want to do two harder ones so y'all could look at those. All right, so that's the lesson. If you have any questions, send me a message on Remind or ask me in class tomorrow. I hope that helps. Thanks.